Hello. Today we're going to look at chemical nomenclature. We're going to investigate naming and writing formulas for very simple binary ionic compounds. We're not going to get far in depth because this is only first 6 weeks, but we're just going to give a little taste of formula writing. Okay, to do formula writing, you're going to need your test periodic table. You should have picked one up when you came to class today. You'll need to memorize the following group charges. Group 1A, positive 1. Group 2A, positive 2. Group 5A, negative 3. Group 6A, negative 2. Group 7A, negative 1. This is an example of the test periodic table that you picked up in class today. Every single time that you do formula writing for a test or a quiz, you're going to get a periodic table that looks exactly like this. Notice there's a lot of information on it. There's some information that I want you to memorize. So if you have your test periodic table handy, I would like for you to fill in the different group charges for some of the representative element A groups that I would like for you to memorize. So I'm going to put the ones that you need to memorize up on the screen now. You need to know that group 1A has a positive 1 charge, group 2A has a positive 2 charge, group 5A, negative 3, 6A, negative 2, 7A, negative 1. I've gone on and added here that the metals, starting with aluminum, in group 3A have a positive 3 charge. Boron doesn't usually make ions. And as for group 4A, carbon and silicon, most likely, if they make an ion, make a negative 4 charged ion, and the metals in that group make a positive 4 ion. I'm not so concerned about group 4A with carbon and silicon because carbon and silicon usually don't make this kind of compounds, and the other elements in the group are dealt with in this chart above. Okay, you need not be scared. You're always going to get this periodic table. You do, however, need to memorize the group charges for the representative elements, as is indicated here. So marking your periodic table now is a good idea. So let's start off with the rules for naming simple binary formulas. Our formulas are going to contain one metal and one nonmetal element. And the rules for naming compounds that contain one metal and one nonmetal are pretty simple. The first rule, name the metal ion first. The second word in the name is the nonmetal ion name. How do we make that? We simply take the nonmetal element name and change its ending to the IDE suffix. So if your second element in a formula is the element nitrogen, you would change the name of nitrogen to nitride. If the second element was oxygen, you would change the ending of oxygen to oxide. It's pretty simple. And in fact, you can find a simple list of nonmetal ion names on the back of your test periodic table today. Now, here's an example. How would you name the formula MgO? Well, if we follow our rules, we're going to name our metal ion first, followed by the nonmetal ion name ending with IDE. So if you take a look at your periodic table, or you remember your elements that you memorized, the first element is magnesium, the second element is oxygen. So the name of this formula is simply magnesium oxide. It's pretty easy. Here's another example. Let's try to come up with a name for this one. BaCl2. Remember, name the metal first, followed by the name of the nonmetal. This one's a little bit different though. I've got a subscript already in the formula. Does the 2 subscript matter in this name? Will it have an effect on how we name the formula? In 99% of the cases, subscripts in simple binary ionic formulas don't really play a role in the name. And in this case, it doesn't. So we can just kind of ignore this little 2 at the moment and name the formula simply by naming the metal, followed by the nonmetal ion name ending in IDE. So since my first element is barium and my second element is chlorine, my name of the compound will be very simply named by our simple rule. So what is the name of the compound? The name of the compound is barium chloride. At this point, you probably think naming seems too easy, so there must be a catch. And unfortunately, there is one complicating issue regarding transition metals. Okay, so let's take a look at our periodic table again. Outlined in orange are the transition metals on the periodic table. This hunk of the periodic table has a distinction because of the elements in this particular area of the periodic table have the ability to make more than one ion form. So formula writing with them is a little bit more challenging, but it's not so bad. Now, you can take assurance at this moment that I'm always going to let you use this little periodic table, and this little group chart at the top is going to show you the formulas and charges for the most common transition metal ions that we will use. So if I were to point out this one, cobalt, CO positive 2, is called the cobalt 2 ion. You get both the name of the ion and its charge, and you're always going to be able to reference that. So let's get some examples for how to name a compound that uses a transition metal. Okay, I've got two formulas for you here, PbO2 and PbO. They're both correctly written formulas. They both represent real chemical compounds. But if we follow our simple naming rules, then both of them would be named lead oxide after the first element and second element. That seems like a pretty dangerous thing to do in chemistry, to have two different formulas named by the same name. So you can see there's a dilemma that exists in chemical compound formula writing. It's much like a situation like a teacher might have in class if they have two students with the same name, like two Steve Smiths. How do you distinguish between the two different entities? Well, in the case of two students named Steve Smith, you would probably differentiate them by having them sign their papers with their middle initial. And we're going to kind of do the same thing with these compounds. We're going to look at the transition metal ion and use its appropriate Roman numeral name as sort of a middle initial. So we're going to update our little formula rules. Our formula rules now are going to be name the metal ion first. The second word in the name is the nonmetal ion name. It's simply the nonmetal name with an IDE suffix. Roman numerals should be used in the name whenever you have a metal that has more than one charge state. And the Roman numerals should follow the metal name. So you can think of the Roman numeral as kind of the middle name for this kind of compound. So let's try to name these again. Let's figure out what the name of PbO2 and PbO are. If I check my transition metal chart at the top of the periodic table, I'll find that I have two different leads. I have Pb positive 2, which is called the lead 2 ion, and Pb positive 4, which is called the lead 4 ion. Each has been given a different middle initial, or Roman numeral. And that'll help us differentiate between each ion in a compound name. So if we're going to try to name these guys, that means one of the formulas is called lead 2 oxide and one of the formulas is called lead 4 oxide. But now we still have another dilemma. We know that they're both lead 2 and lead 4 oxide, but which one is lead 2 and which one is lead 4? Okay, we're going to need a little bit more information. So to help us out with this, we're going to kind of switch gears for a minute, and we're going to take a look at writing chemical formulas when you're given a name.